No, that is not what science teaches us. I'm sorry to say.
Universe is random. It's not inevitable. It's simple chaos. It's subatomic particles in endless collision. That's what science teaches us.
That's what science teaches us? No, that's not what science teaches us. I'm sorry to say, anytime anybody says that science says blank, they're trying to pull something over on you. Science doesn't say anything. It's scientists that say things, but science can't say anything. Literally, it's not an agent that acts and has beliefs and thoughts and can express them through language. It can't say anything, literally. Science, literally, the word itself, is from the Latin word scientia, which just means knowledge, translated literally. So it means knowledge. So science is just a body of knowledge. That's all that means. And so it means that these are things that we've discovered, and we've laid them out. We've codified them. We have disseminated them among the people. And this is what knowledge says. Well, I mean, knowledge, again, doesn't say anything, but it's what people have said when they've added to our body of knowledge. And it's a whole different enterprise, of course, according to how to interpret what those data points say. Again, when it comes to the data itself, rarely do you see, just think about it yourself, when you see somebody on social media saying, science now says chocolate is bad for you. And then, of course, next week, science now says chocolate is good for you, right? Have you ever, in any wild claims being made where science says such and such a thing, have you ever actually read the study yourself or seen the data points, seen the actual statistics based on the study that they allegedly done? No, you haven't. You have read, maybe if you've even, which I doubt it, if you've even tracked down the actual article instead of reading some sort of public-facing summary of it or something where some editor, writer, contributor, has summarized it based in like everyday language, which is nice. That's a nice service to provide to people. But if you have done more than that and like clicked through to the actual scientific article, say on PubMed, IH or something, you probably haven't looked at all the graphs and charts and everything and seen the statistics. You might have read the summary abstract and seen there's a section usually in those articles that delineate the findings from such study, the review, the results, the summary of results, right? You've read that perhaps, but it might be like 2% of people who have done that. But all that goes to show is that you're reading what people have said about the data points. So yeah, when it comes to chocolate being healthy or unhealthy for you, sure, it's not that controversial. It'll change next week. And perhaps you're just going to continue doing what you have always done. But when it comes to really controversial things, where in politics, people say, trust the science. Our side trusts the science. Your side doesn't trust the science. Science says, right? Then it becomes very controversial. And you better know that it's not science saying, it's scientists saying that. Or probably more likely, it's science fanatics and fans who have read a little bit and say the things, that they think the study or the data is saying. So this is not as cut and dry as you might think it is. Yes, science is very precise. It's very exact. It gets us really definitive results. But especially when it comes to controversial issues, controversial moral issues, controversial worldview issues, like it's not going to be as cut and dry. It's going to be open to interpretations, because not that the data is open to interpretation. Well, the data isn't. The data are what the data are, but people have to interpret the data. So back to this quote from Walter White, he says, it's subatomic particles, simple chaos, subatomic particles and endless, aimless collision. And that's what science teaches us. Endless, aimless. Well, aimless, not necessarily. Science, But let me put it to you this way, all right? If you really want the nuts and bolts of this, right? Back when Aristotle was doing his thing 2,400 years ago, he had a concept known as the four causes, right? You had formal, material, efficient cause, and final cause. Efficient cause is normally what we take to be sort of a cause and effect, right? This came before that, so a billiard ball upon a pool table hits one, and that was the cause of the other one, proceeding and continuing. Formal material, right? So let's just put it this way. Suppose, actually, these four causes, that's the one we normally take in terms of like the word cause, but these four causes, these are not just causes for Aristotle. These are explanations. And he says just as much if you read his work on this. He says that these are explanations as to whys, right? They're not just causes in normal everyday parlance. But so take, for example, you suppose I'm your roommate and you see me, I've left the room, but you see what I've left. I've left a boiling pot of water on the stove, and you're very curious. So you, of course, have questions. You ask, why is there a boiling pot of water on the stove? And that could be answered in multiple different ways. Well, one, it could be that, this is probably not the answer you're looking for, but it could be because of the material cause. Could be that, well, based on the matter, it's metal and it gets hot and there's water and we should be at boiling point. And so now it's boiling. Like you probably think I'm a jerk if I answer it that way. Or I could answer it formal cause. I could say the explanation as to why the water is boiling, because that's what you want to know the answer to. Why the water is boiling is because of the form or the shape. You can't boil something that's flat. You have to have a container which contains the water. You have to have gravity, right, that pulls the water down. You can't like boil water in like International Space Station or something. So based on these parameters, that's also why the water is boiling, those together, like the form, the shape that is of them, and then the thing of which it's made. And then there's the efficient cause, of course, which was already discussed. I could say to you, and this bear with me, you probably wouldn't like this answer, but it would be a correct answer. Why is the water boiling on the stove? It's because, I took the pot, I filled it up with water, I proceeded then to walk to the stove, place on stove, that you're not going to be appreciative of that answer. Probably what you want to know is the final cause. This is the telos in Greek language. Telos means end or purpose or goal or something aimed at, the purpose for which we do something. So a legitimate, proper answer, and probably the one you're looking for, to why is there water boiling on the stove, is because I wanted to make tea. Right? Now, science, Walter White has said here that it's endless, aimless, or whatever writer has written for the show. Great writers, I have no problem with them. Great stuff. Although it was a weird episode, of course, The Fly, super duper weird. I didn't like it. Some episodes are great, some episodes are, and this is one of those ones. But aimless. Remember, we said telos, that fourth cause is purpose or aim or goal. That thing that we aim at, that end, the purpose for which we do something. Now, in science, philosophically speaking, there has been a tendency to drop that fourth consideration altogether with respect to scientific investigation. And it makes sense because when you're thinking of the natural world, right? These things, if you think that, say, a moon has a purpose, well, you're going to very quickly end up at the idea of a creator who created that moon and gave it a purpose. So you have to kind of go with, if you're a scientist, you have to go to sort of, let me finish this thought first. If you're a scientist, you have to kind of go for, maybe we won't consider purpose. Now, that doesn't mean that if you're a scientist, you have to be an atheist. Now, this is not metaphysical naturalism. Naturalism is, of course, the opposite of supernatural. Supernaturalism isn't a word, really, that we throw around, but, it's basically supernatural would be the idea that you think the supernatural exists. There are angels, demons, God, devil, so on and so forth. There are spirits, souls, the afterlife, and so on. That supernatural world really does exist. It's real, although not easily accessible or visible, of course. but these things are real. They do exist. Now, naturalism is a denial of that. It is not that the supernatural exists. It believes that only the natural world here exists. Now, that's metaphysical naturalism. Without a metaphysical worldview. But science does not ask anybody to believe in metaphysical naturalism, but it does ask for you to buy into and proceed with methodological naturalism. The idea that for all intents and purposes, right, when we do our experiments in the lab, say when we're measuring the liquid in the chemistry lab to see, what the measurement might be or what might happen, we assume for the purpose, methodologically speaking, for the purpose of just doing this experiment right now, only that we are considering the natural world because that's really all we can observe. That's all that's saying. In other words, we're not going to assume that, some angel kicked it over and that's why it spilled, or that's why it gave a certain result, returned a certain result, that we didn't like or something. We're not going to start to invoke supernatural deities or something like that. But that's methodological naturalism, not metaphysical naturalism. That means that you can be a theist. You can be a really robust believer of any religion and still think that you can still do the work of science. You can proceed methodologically as if not as if the natural world only exists, but as if you're only going to consider the effects of the natural world, because again, you're only using your observations empirically. Now, it is worth noting that many people in science have been people of faith. In fact, many Nobel Prize winners in science have been people of faith. If you look, there's a Wikipedia article called Christians in Science and Technology, or list of Christians in Science and Technology. Look at that. And in fact, there was a study, sort of a meta-study done over the last 100 years of Nobel Prizes, a review, quote, according to 100 years of Nobel Prizes, the publication name, a review of Nobel Prizes awarded between 1901 and 2000 reveals that 65.4% of Nobel Prize laureates have identified Christianity in its various forms as their religious preference. So they consider themselves Christians. Now, these, of course, are really brilliant people having won Nobel Prize. These are not just, the numbers would significantly go up, I think, if you included all scientists over the last 100 years. But these were outstanding, excellent people in their field that won Nobel Prizes in all categories, science and otherwise, and well over 50%. A vast majority of them have been Christian. And then if you want to lump in and include not just Christian, but say all Abrahamic faith traditions or all religious people, like it'd be interesting to see the details and the statistics on that as to how many people would be atheists versus how many people would be religious. And I think that if you're skeptical about this actually might surprise you. So all that to say that Walter White is making this really bold claim as to that's what science teaches us. It's just subatomic particles and endless, aimless collision. Not so fast, Walter. I'm sorry. I love you, but it's not aimless. And that's not what science says. That's what scientists say. And turns out that it's actually a minority of scientists that say that. Of course, if you're not subscribed, let this be a reminder from my wife to make sure you subscribe. And I look forward to hearing from you next time. Take care.